All right, so today's solving is what happens when your variables cancel out. They're over there. The notes should be up there. All right, so what happens when your variable cancels? You guys ever do that? You get solving and you like move your x's over and you're like, oh, they're gone. Letters to the left. I know some of you like that. But what happens when you solve an equation? One of three things could happen, okay? So the first thing that could happen is you get one answer, which everything yesterday, you got one answer, right? You went through, you got x by itself or whatever the variable was, x equals 4. We got a number. It may not have always been a pretty number, but you were able to solve it. All right? But there's other things that can happen. Your variables can cancel out, and then you can get an answer of all real numbers or infinitely many solutions. You know mathematicians are lazy, right? That's a lot of words to write. So what we can do is we can use a symbol to make that easier. And you'll see me use the symbol all the time. The symbol for this looks like that. That stands for all real numbers. So you start by just making two straight up and down lines, two parallel lines, and then just make your R on it. Yep. So it's an R that's got an extra line in front. That stands for all real numbers. Lazy mathematician, you want to use that symbol? You absolutely may. It's way faster to write than all of that. When this shows up is when your variables will cancel. So you get to a point, you subtract your x's, and you're like, they're gone. They cancel it out. But the numbers that are left, they're equal to each other. Like it might be 4 equals 4. -7 equals -7. 7,000,003 equals 7,000,003. Doesn't matter what they are, but they're the same. So when that happens, that means it doesn't matter whatever number you want to plug in for x, it's always going to work. Okay? But there's times when your variables cancel and you get no solution. And that's when the numbers that are left are not equal. For example, I get 4 equals 7. Then no matter what I plug in for x, it's never going to work. And again, mathematicians are lazy, no solution. That's still too many words to write. I can just make a circle with a slash through it. That means no solution. Okay, so feel free to be a lazy mathematician and use the symbols, okay, because I will. All right, so let's go ahead. We're going to do, I think I have 5 examples in here today and then like one other little thing at the end. So number 1, when we are solving, again from yesterday, don't lose your equal sign. What should we start with? Yeah, we got some like stuff going on in here. So I have 1z plus 3z, 4z. I have a -6. On this side, we have 1 minus 7, which is -6, plus 4z. And then if I wanted to move my variables, right, I would subtract 4z on both sides. And what happens? Those cancel. And I'm left with -6 equals -6. So that is all real numbers. So meaning if I would go back, like we checked our answers, I showed you guys yesterday how to check them. If I would go back to the beginning, I could plug in any number I want for z, and it's going to work. Somebody give me a number. 12. So wherever you see a z, I'm going to put a 12. Right? So I'm going to be lazy, use my calculator here. So 12 minus 6 plus 3 times 12. This side would give me 42. If I do that side, 1 plus 4 times 12 minus 7. I get 42. Plug in a 17. I don't care. 17. 17. So 17 minus 6 plus 3 times 17. I got 62 that time. So if I plug it in on that side, 1 plus 4 times 17 minus 7, I get 62 again. Doesn't matter. Whatever you plug in. 6,305,700. I don't care. Plug it in on every spot. It's going to work. Okay? So that's what that means. When your variables cancel, either all real whether everything I put in is going to work or nothing's going to work. Okay? So if that happens to you and these equal, we know it's all real. All right, number 2. So this one, again, look where your equal sign is. I got some like terms over here. 12t minus 7t. That's 5t. Okay, and then I'm going to move my variables to get them all together. So I subtract 5t. And they cancel. So now I have negative 3 equals 3. Yes? No? Does negative 3 equal 3? No, those are not the same. That is no good. So this is no solution. It does not matter what you try to plug in for t, nothing's ever going to work. Doesn't matter. No matter what you try, nothing will ever make this side equal this side. Now, the thing I find students mess up the most is just like you were saying, you keep losing your negative signs. As students look at this and they get to here and like, oh yeah, those are the same. I see 5t, 5t, I see a 3, 3, they're fine. It's all real answers. But be careful, one's a negative, one's a positive. Or if this was a 5t and this was a negative 5t, would they cancel? Mm-mm. So be very careful, watch your signs, okay? All right, number 3. What should we do first? Good, let's distribute this. So 12c plus 8. Distribute over here. We get 10 plus 12c, negative 2. Are you going to add it? You subtract. Yep, there's a minus in front. So that's going to give me 8 plus 12c. Okay. So I distributed, collect like terms. Let's move our c's to one side. So I'll subtract 12c. Those cancel. I get 8 equals 8. What's that mean? All real. No matter what I plug in, it's going to work. Aren't they nice? Number 4. What do I do with that first? Distribute what? How do I just kind of erase it? Yeah, remember that's like a -1 that's being distributed there. All right, so I'm just going to rewrite all of this. 7y minus 5 plus 2y equals 3. -1 times 8. It's -8. And then -1 times 9y will be -9y. So how badly does missing one negative sign mess up your problem? The whole thing. It's catastrophic failure. Okay, so just take your time, guys. Go slow. All right, from here, got some like terms going on. 7y, good. That would make 9y minus 5. And over here, yep, sure would. -5 minus 9y. You want to subtract 9y or add 9y? Add 9y. Does it cancel? No, that's 18y. Minus 5 equals -5. Good, then we'll add 5. So 18y equals, what's that? It's 0. Guys, 0 is a number. Everybody panics when you get a 0. I think one of your homework problems didn't have a 0 on it, and everybody like panicked. It's just a number. And then to get y by itself, we divide by 18. What's 0 divided by 18? Grab your calculator. Yeah. Yeah, you're thinking backwards. 0 can be on top, 0 can't be on the bottom. Yeah, you can't divide by 0. If 0's on the bottom, it's no solution. It's bad. Yes. Cookie Monster's sad. He has no cookies. You've never heard that? good time to play this, right? Hey Siri, what's 0 divided by 0?
Imagine that you have 0 cookies, and you split them evenly among 0 friends. How many cookies does each person get? See, it doesn't make sense. And Cookie Monster is sad that there are no cookies, and you are sad that you have no friends.
Isn't it sad? It's funny. Gosh, you really never asked for that one. All right. So 0 divided by anything is 0, but you cannot divide by 0. Can't be on the bottom. 0 on top is fine. It's just 0. All right, number 5. I distribute 5e plus 15. All right, hold on. Slow down a minute. Let's wait for your classmates to catch up. Some of them hadn't even flipped the page yet. So always distribute first. Then we will collect our like terms. I got some like terms over here. So I have 5e plus 15. That's going to give me 5e minus 9. And then I'll subtract the 5e. And what happens? It canceled. So I have 15 equals negative 9. Yes? Does 15 equal negative 9? No. That's not good. So my answer is there is no solution. So variables cancel. You're either going to have all real or no solution, whether it's equal or if it's not equal. Or you can go through and actually get an answer, right? That's what we did yesterday. We actually went through and got answers. All right, questions so far? All right, and then the other thing we need to look at is, this is something I feel like students struggle with all the time, is finding errors, okay? Like, there's nothing worse than, like, students come up and, like, they're bringing me something, they're like, is this right? And I'm like, nope. And they're like, well, what'd I do wrong? I'm like, go look at it, see if you can figure it out. And then they get mad at me. Heaven forbid I make you look at your work and find your mistake, okay? So this is something I want to try to work on this semester, is you guys finding where the error happened, okay? So Mike solved this equation as shown. So if you look, it starts with the actual problem. It says given. If you think back to geometry and proof days, we're not doing proofs, I promise. No proofs. But here's the problem it started with, and then it just kind of goes step by step to show you what he did. And I'm telling you, there is an error. So can we find it? Yeah, I think there was one on there. So honestly, guys, when a problem like this, when you're like trying to figure out the error, don't just stare at it. It's not going to jump off the page at you. Go through the process. What would you do if you were going to solve this? I would distribute, right? So 5 times 2z, yep, that's 10z. 5 times negative 3, negative 15. They brought down the minus 5, equals 3 times 4 is 12. 3 times negative 3, negative 9. And they brought down the plus z. So at step 1, did they make any errors? No. Step 2, yes. If you look, there's the 10z. Hold on. They went ahead and put, these are like terms, right? That's what we would do. We'd put our like terms together. That's negative 20. That's right. Here's the 12. These are like terms. Negative 9z plus z is, that's negative 8z. They said it was negative 10z. All right, so if you look at the problem, part A, find and explain the error that Mike made. So can you tell me, what did he do? Good. Like, honestly, guys, I'm okay that I'm a math teacher. I'm not a write in full sentences kind of person, okay? That's why I didn't teach English. For me, if you're looking at, and you could write negative 9z plus z equals negative 8z, and then you might just want to tell me he did negative 9z plus z equals negative 10z, which is wrong. Okay, in math, you can explain a lot just by showing work. Okay, so I don't actually need sentences. If you're somebody who likes sentences, by all means, you're more than welcome to write them. I'm not going to count it wrong, but you don't have to. Okay, so just kind of recognizing where that error took place. Part B, what is the correct solution to the original equation? So what do I need to do? I need to finish solving it. Do I have to start at the beginning? No. I know the error took place here. So I'm just going to kind of pick it up from there. 10z minus 20 equals 12. Shouldn't be minus 10z. Should have been minus 8z. Right? If it makes you more comfortable and you just want to start at the beginning and start it over, you can. That's fine. I'm a lazy mathematician. I'm going to start right where I saw the error took place. So to finish solving it, right, I got z's on both sides. I'm going to go ahead and add 8z. So we have 18z minus 20 equals 12. Good, we'll add the 20. So 18z equals 32. Divide by 18. What's z equal? 16 times 2 is 32, not 18. So, guys, when you're looking at a problem like this, just simplify the fraction. Just 32 over 18, simplify it. It's 16 over 9. Again, you can always use a calculator in here. I'm never going to take those away from you. Okay, so feel free to get used to them, get comfortable with them. Some kids in my Algebra 2 class during A block, they weren't using a calculator. I'm like, but they were struggling with some of the basic stuff. I'm like, why aren't you using the calculator? They're like, well, I don't know how to use the graphing ones. Great, you're not graphing. What's the problem? Push some buttons on it. Like, they were just too afraid to even touch them. Okay, don't be that person. I will help you figure out the basic controls of that thing. Okay, if you have questions, just ask. All right, so questions on anything we did today?